we have looked at limits of a function. Now let's look at continuous functions. What does it mean when we say continuous function? A function f of x defined near about of a point A and also at A is said to be continuous at x equal to A. So what this means is, if we draw a graph, then at this point, let's say this is A, there is a corresponding value f of x which exists, or rather f of A exists. And if we take the limit, that is also the same as f of A. And the way we write this is limit as x approaches A of f of x is equal to f of. So what does this mean? By looking at the definition itself, we can figure out that there are three conditions. F of x is defined at x equal to A. There are no holes. So that is f of A exists. Second point is the limit as x approaches A of f of x exists. That means what? LHL and RHL exists. Left hand limit and right hand limit exists. And finally, the above two are equal. That is limit as x approaches A of f of x is equal to f of A. In other words, we can say a function f of x is said to be continuous at x equal to A if for every epsilon greater than 0 there exists a real number such that, let's say this is delta, real number delta, such that f of x minus f of A is less than epsilon whenever x minus A is less than delta. In still other words, we can say a function f of x is continuous in an interval a comma b if it is continuous at every point of the interval. Now, why are we interested in continuity? Because that helps us in differentiation, in figuring out whether something can be differentiated or not. Now, continuity of a function f of x at the end points of the closed interval a and b is, now remember here we are focusing on end points. F of x is continuous at x equal to a if, as x approaches a from the positive side, that is from the right hand side of f of x is equal to f of a. Second is f of x is continuous at x equal to b if limit as x approaches b from the left hand side of f of x is equal to f of a. So let's look at a graph. Okay, now here what happens? If we want to know the continuity at, let's say, A and B, in case of A, we have to come from this side only, because on the other side it is not defined. Similarly, here at this point, this was at this point. At this point, we have to come from this side only. So that is what these 2 points convey. Now let's look at some examples of continuous functions. Constant function, so f of x equal to k for all x belonging to set of real numbers. So which means basically what? That x doesn't appear in the actual definition of the function itself. So it doesn't matter what the value of x is. Identity function. So f of x equal to x. So usually this will go like this, right? Again, for all x belonging to set of real numbers. And the third is any polynomial function. So which means what? Say f of x is equal to, an example is 3x plus 4, or another example could be 3x square plus 4x plus 2, or we could have a cubic, so 4x cube plus 3x square plus 4x plus 1, or 1 plus x square. Here the important thing is that this x should not appear in the denominator in such a way that the denominator can become 0. So in all these cases, for all x belonging to real number. Now, just like we can have continuous functions, we can have discontinuous functions. Now, when can we say that a function is discontinuous? Any one of these, if it is true, the function is discontinuous. F of x is defined near a, but not at a itself. Second is limit as x approaches a of f of x does not exist. And finally, the limit exists but is not equal to f of a. So what does this mean? By direct substitution does not work at x equal to a, right? Here LHL, RHL does not exist, and here limit exists but not equal to f of a. So for it to be a continuous function, all those three conditions have to be true, right? All these three conditions have to be true. Whereas for it to be a discontinuous function, any one of these conditions have to be true. Okay, now let's look at types of discontinuity. One is removable discontinuity. So let's say y is equal to f of x is defined at x equal to a. Limit as x approaches a of f of x is not equal to f of a but exists. So therefore not continuous at x equal to a. So graphically, if we have to look at it, we can put it like this. So exactly at this point, the point, f of x may be here, right? So f of x keeps going on this line, but the moment it reaches a, it jumps here, and then the immediate next, again it continues on the curve. So how do we remove this? Because it says removable discontinuity, what we do is we just say that f of a is equal to the limit as x approaches a of f of x. So whatever is the limit, we put it in f of a. So which means what? In a way, we catch hold of this point and drag it onto the curve. It's as simple as that. And this point we can say is a point of removable discontinuity. So simplest example is let's say you are collecting data. Okay, now the second type is discontinuity of the first kind, such a imaginative name. So let y is equal to f of x be defined at x equal to a, and limit as x approaches a from the left hand side f of x. Now this is not equal to the limit as x approaches a from the right hand side are not equal, but both exists. They both exist, the only thing is they are not equal. So here curve is going like this. So from here to here it goes, and then suddenly it jumps to here and then continues. So here the limit exists, but they are not equal at this. For this point the limit exists, but it doesn't equal each other. Now in this case, if limit as x approaches a from the left hand side of f of x is not equal to f of a, then a is a point of discontinuity of the first kind from left. If limit as x approaches a from the right hand side of f of x is not equal to f of a, then we can say a is a point of discontinuity of the first kind from right. And then we have the third type of discontinuity. Very imaginatively, discontinuity of the second type or second kind. Okay, so let y is equal to f of x be defined at x equal to a. Now limit as x approaches a from the left hand side of f of x, and the limit as x approaches a from the right hand side of f of x, they both does not exist. So in the first kind they both exist, they are equal to each other, the limits, and it is defined at that point as well. So it is called removable discontinuity. Second one is both the limits exist, but they are not equal to each other. In the third type, the limits themselves don't exist. So that is continuous functions, discontinuous functions, and types of discontinuities. In the next session, we will look at some problems being solved based on this. Problems in terms of figuring out whether a given function is continuous or not, and if it is not continuous, what type of discontinuity it is. That's it for today. Bye for now.